mission for the Capstone project of the Machine Learning Engineer with Microsoft Azure Nanodegree program by Udacity. So I'm working with the cervical cancer risk factors dataset. It comprises of demographic information, habits, and historical medical records of about 858 patients from this particular hospital in Venezuela. My target variable is biopsy. Biopsy is the variable which contains whether the person had cervical cancer or not, whereas these are the preliminary tests and these are the attributes I'll be using. So moving on to my notebook, I'll start with hyperparameter tuning using hyperdrive. So I got my imports first, configured my workspace to have my experiment in, and configured a compute cluster to run my hyperdrive policy in. So being a classification problem, I'll be using logistic regression, which is configured in my train.py. So in my train.py, I start with cleaning my data. These question marks greater than signs, these represent the values which are not shared as a part of the data set due to privacy concerns. And furthermore, I return the values x and y contains the biopsy or target variable, and hereby I define this argument as this is my regularization strength, inverse of regularization strength actually, and maximum iterations, and I'll be using the average precision score weighted metric because this data set has some bias. So I will be using this over accuracy, as with accuracy it will give us an appearance that the model is performing well, but actually might not. This is being taken from sklearn metrics. So hereby going back to hyperparameter tuning. So I'm using the banded policy and as the early termination policy and random parameter sampling for parameter sampling, and as I explained, weighted average precision score as my primary metric. So here I configured my hyperdrive run and I submitted my run, and as I can see my details over here in this run details widget, and it succeeded. Yeah, it succeeded, it's completed, and average precision score was maximized. So that the best model I have gave us the precision score of about 0.104 with 1400 iterations and about 0.5 as the regularization strength. And this was, I registered this model, but this was not the best performing model. The best performing model came from the AutoML, which performed far better than this model. So again, I start by getting my imports, getting my workspace, getting the dataset. I use the tabular dataset factory to get it as a tabular dataset, and my clean data function is the same function I used in hyperparameter tuning. It's present in my train.py. So this converts it into data frames, and cleans them and bring them in usable format. Furthermore, I divided my data into training and testing for usage. Put it in my data store, put my data set in my data store to actually use it in my AutoML run. Here's my training data, and I also configured a compute cluster to run my AutoML on it. So here are my AutoML settings. It has the experiment timeout went of 30 minutes because it has about 730 rows. So that time is enough. 4 concurrent iterations because I'm using a compute cluster with 4 nodes and 5 cross validation to prevent overfitting. And as explained earlier, I'm using the average precision score weighted as the primary metric, same as hyperparameter tuning for comparison purposes. And of course, I have enabled ONCS compatible models as well, as I'll be retrieving the ONCS model as well. Furthermore, I submitted my experiment, and as you can see, it also alerted me for class balance and detection, as I explained earlier. So a model's accuracy, so it falsely perceived positive effect on a model's accuracy. That's why I've not used accuracy, as there are only about 183 people in my data set who actually had cervical cancer, and which means about 500 people who did not. So here are my runs. The models created, and the best model was the voting ensemble with 0.906 scored, and the run is completed, as I can see in my run details widget as well. And here is the values of the best model. I got it over here, the much level over here, and yeah, I registered that model. I also retrieved the ONCS model, and I can also make predictions with the ONCS model. As if I run over here and I get the predictions and the probabilities of the predictions. So that is my model, ONCS model, and I deployed my model because this was the better model. So again, getting my imports, getting the model itself, getting the model itself, getting the files required for the model, that is the environment file required for the model to run on, the scoring file and the inference configuration to score the file, and then Azure container instance web service to where I can deploy my model as a service. And here I deployed my model as a service. As you can see, this is my service, and waited for deployment as it eventually succeeded. It was healthy, and I got the scoring URI and the Swagger URI as well. And I also, because I have authentication enabled, I also require a primary key for using this. So I retrieve some data to actually test it, and I'm running it in the endpoint.py. So if I run it, it gives me the result, which is actually the same result as the information itself, the data set itself. So going to the endpoint.py, I have the scoring URI from my model, I have my key and the data. I have already configured it, and when I run it, I get this response. So that was for the endpoint.py, and I can also enable logging with logs.py. So going over there, I have my logs.py, get my service enabled. I also enabled application insights and I get the logs from the service. 200 is an OK response. I got these from the name of the model itself. I also have enabled application insights, which we can see over here in the endpoints tab. So in the endpoints, you can see that the application insights URL it enabled was true, and over here I can actually find the insights, which you can see which came up during testing. And that's about it. That's my time. Thank you.